Identify the equivalence point of the titration. The equivalence point on a titration curve of a weak acid with a strong base is represented by the point of maximum slope, the center of the near vertical region of the pH curve. On the provided graph, this sharp vertical inflection occurs at exactly 20.0 milliliters of added NaOH. Calculate the concentration of the NaOH titrant. At the equivalence point of a titration involving a monoprotic acid, the moles of added base, NaOH, must be stoichiometrically equal to the initial moles of the acid in the sample. Moles of acid equals moles of NaOH using the molarity and volume relationship. MAVA equals MBVB, 0.10 molar, times 20.0 milliliters, equals MNaOH times 20.0 milliliters. Solving for the molarity of NaOH. MNaOH equals 0.10 molar times 20.0 milliliters over 20.0 milliliters equals 0.10 molar. This narrows down the correct choice to either option B or option D. Identify the half equivalence point. The half equivalence point occurs when exactly half of the volume of strong base required to reach the equivalence point has been added. V half equivalence equals V equivalence over 2 is equal to 20.0 milliliters over 2 is equal to 10.0 milliliters. Relate the half equivalence point pH to the pKa. At this halfway point, exactly half of the weak acid, HA, molecules have reacted with the added OH to the power negative to form the conjugate base, A to the power negative, resulting in equal concentrations of the weak acid and its conjugate base remaining in solution, HA equals A to the power negative. Substituting this equality into the Henderson-Hasselbalch equation, pH equals pK A plus log A to the power negative over A, pH equals pK A plus log 1, therefore pH equals pKa. Determine the approximate pKa value from the titration curve. Find 10.0 milliliters on the horizontal axis, volume of NaOH, and read the corresponding pH value on the vertical axis. The curve passes slightly below the 5.0 grid line at a pH of approximately 4.7. Therefore, pKa approximately 4.7. Combining both pieces of information, pKa approximately 4.7 and NaOH equals 0.10 molar. We confirm that option B is the correct answer. The correct answer is option B. pK equals 4.7. NaOH equals 0.10 molar.